Let's look at our first example. A research ship sends a sonar power straight down into the ocean to measure the depth of the seabed. The speed of sound in seawater is 1,530 meters per second. If the ship's equipment detects the echo exactly 4.2 seconds after transmission, calculate the depth of the ocean floor at that location. So let's write down everything that's given. What is given? The speed, which is 1,530 meters per second. We are given the time. This time is the time for the echo. Please keep that in mind. 4.2 seconds. What do they want us to calculate? They want us to calculate the depth. That is our unknown, the depth. Okay. So now what is happening here? I placed that picture there to show you something. That's a boat. And they're transmitting. Transmission, remember, they're the ones who are sending the sound. So they're sending a sound to them and they hit the bottom of the seabed. And then what happens? Sound is reflected. Sound bounces back. So the moment this sound reaches their ears, that side, the time would have been 4.2 seconds. Meaning, the time it went down, T1, plus the time it went up, T2. That gives me what? The time for the echo, which is 4.2 seconds. Now, the question is asking for the depth. The depth simply meaning how deep it is. So, the sound traveled from the boat to go down. The distance that the sound traveled, that's distance 1. So the time they gave me, the time of the echo, it's actually the time when the sound traveled going down, distance 1, and then the sound came back, distance 2. So this echo that I'm getting here, it's for the total distance that the sound traveled. So if I use that information exactly as it is, what am I actually calculating now? I'm calculating the total distance that the sound traveled. So the next step is finding the formula that relates everything that's given and that is unknown. And the formula that does that is V is equals to delta X over delta T. Notice that is small t, not capital T, because I'm talking about time and not period. Now, the last step is substituting and solving. So when I substitute my V, 1,530, my delta X unknown, the time for the echo, it is 4.2 seconds. When I do it this way, the answer that I'm going to get for delta X, remember, it's for what? The total distance that the sound traveled to go down and then bounce back up. So that means what? My delta X is equals to 1530 times what? Times 4.2. How did I get to that step? I cross-multiplied. Basic mathematics. Okay. So now my delta X, it is going to be 6,426 meter. Remember, an answer without unit, it is wrong. This is my delta X, simply meaning the total distance that the sound traveled. The question was asking for what? The question was asking for the depth. So to get the answer for the depth, what am I going to do? I am going to say depth is equals to the delta X that I got, and I'm going to divide it with a 2, because I just want to know how deep that is. So it is going to be what? It is going to be 6,426 divided by 2. Our depth, it is going to be 3,215 3 meter. So that's how deep the ocean is. But there's another way of doing this calculation. So that was the first method of how you can calculate the question, the depth. But now, because I understand what this means, I can now know how long it took for the sound to go down. So my T1 is going to be 4,2 divided by 2, which is going to give me 2,1 seconds. That is the time the sound took to go down. I know the speed that it traveled to go down. It's 1,530. I do not know how deep it is, so I'm still looking for the depth. I go back to my formula. My formula says V is equals to delta X over delta T. I substitute as 1530 is equals to delta X over what? 2,1 second. Same story, we cross multiply. When we cross multiply, what do we get? We get delta X is equals to 1530 multiplied by 2,1. What is our final answer? 3213 meter, which is what? Which is our depth. So it depends on how you understand it. So with the first one, we use the information as it is. Then what did we do? We divided at the end. Let's look at our second example. A hiker stands at the edge of a deep canyon and shouts towards the opposite cliff wall. The cliff face is exactly 510 meters away from the hiker. If the speed of the sound in air that day is 340 meters per second, calculate how long the hiker will have to wait before they hear their own echo. Let's collect the information. What's given? We are given the distance. You can call it delta X. It's fine. 510 meter. And then what are we given? We are given the speed of sound in air. Remember I said to you, sound travels faster in solids than it does in liquids, than it does in air. What is unknown? The time. Now, be careful with this one. The time they want is not the time the sound traveled to go there. No. They want the time the sound went there and the sound came back. So in this one, we want the echo. The time for the echo. The time I hear the echo. What time was it? Same story. I find a formula that combines the given and the unknown. And what formula is that? V is equals to delta X over delta T. My beloved, a formula sheet is given to you in an exam so that you don't have to strain your brain and think. Just go to your formula sheet and locate the formula and just put it there. Don't confuse yourself. And then we do the substitution. So the substituting is going to be 340. So S is equals to what? 510 divided by what? Divide by delta T. I'm putting the information as it's given to me. I'm not complicating my life. Then I do what? I do cross multiplication. And I get what? 340 multiplied by delta T is equals to 510. Another mathematical skill that you need to implement. Divide by 340 on both sides. Why? We want this 340 to cancel that 340. And then we get our delta T as 1,5 seconds. So now, this time that we got is the time the sound traveled distance of what? 510 meter. It took how long? The time was 1,5 seconds. But what do I want to know? I want to know how long it took the sound to go there when I shout and come back when I hear the echo. That's the time that I'm interested in. So it means that this time that I have here, I need to double it, because it's the same time it went there, and it's the same time it came back with. So it means my time for the echo, it is equals to 1,5 multiplied by 2, which gives me 3 seconds. So now let's look at it in a different way. I know that for me to hear the echo, the sound has to travel a distance of 510 meters that way, and it has to travel the same distance again back to me for me to hear the echo. So it means that the moment I hear the echo, the sound traveled double the distance. So I might as well say what? The distance is 2 times 510. I doubled the distance already, because the time I want is the time the sound traveled double to go to the wall and then come back to me. Formula stays the same. V is equals to delta x over delta t. Remember I said we can use delta x here. If you don't want to use d when collecting your data, you can say delta x, it's fine. So this substitution, 340, my distance, I'm doing what? I'm doubling it. So 2 times 510 divided by delta t. Again, cross multiplication, delta t multiplied by 340 is equals to 1020. Where do I get 1020 from? 2 times 510. Then again, mathematical skill, divide both sides by 340, divide both sides by 340. Cancel, cancel. I am left with delta t is equals to what? 3 seconds. So this is the time when I hear what? When I hear the echo. Let's go back to our sketch. So we know we went that way, 510, that is the shouting. And then we came back, 510. That is double the distance. The time I hear the echo, it means it's the time I went there, t, and I came back, t2. So it means my echo traveled double the distance. That is why I have to do what? I have to double the distance. For you to understand echo, you need to understand what you're saying. There is no pattern that I can really give you in terms of answering echo. You need to picture it, visualize it, and understand what are you saying. Don't forget the golden rule. The sound has to travel double the distance for you to be able to hear the echo. It has to travel double the time for you to hear the echo. To wrap up things, remember 3 simple rules whenever you face an echo question. 1, always check if the given time is for a round trip or a one-way trip. A round trip simply means a return trip. You go there and then you come back. That's a return trip. You go to school and you come back to your home. That's a round trip. A one-way trip is you go to school and you never come back home. So that's one way of understanding it. Number 2, when you're calculating the time for the echo, the distance is always doubled. The distance is always doubled. So it's either you are going to double the distance within the calculation, or you're going to double the final answer, the time that you get. So please be clear on what you are saying. And when we calculate for the depth, remember the total distance is halved. So same situation, it's either you're going to have the echo, the time for the echo, or you're going to have the final answer that you got for the distance to get the depth, or to get how far the two objects are from each other. If this video helped you to make sense of sound reflection today, please hit that like button, share with your friends, and don't forget to subscribe. Drop any questions that you have in the comment section below, and I'll make a video just for you to answer your question. See you in the next video. Thank you for watching. Toodles.